Right, laser cutters is the next thing. Ken told me about his S9 Sculpfun some time ago, and I thought that was a good idea, so I bought one. And a couple of weeks after I bought it, the Perishers launched an S10, which was twice as powerful. So I was whinging to Bernard about that, and he offered to buy my S9 so I could buy an S10. So I bought an S10. And this is something about my experience with it and why I love my laser. Okay. This is the Mark II enclosure for it. First off, I destroyed my smoke alarm by running it without an enclosure. It's a bad thing. You've got to have an enclosure if you're going to have a laser. And this is subject to continuous revision. At the same time as I bought the laser, the S9, I thought I'll buy the extension kit because I'm bound to want it sooner or later, which makes it twice as big that way, 900 millimeters. It then makes it much more difficult to build an enclosure, and I've actually never used the twice as big kit. And since I've learnt more about Lightburn, I probably never will need to. So don't buy the extension kit unless you've got a very specific reason to. Fume extraction is important. My first attempt at this, the fume extractor was a bathroom fan, which was okay, but it didn't really shift much air. So this bit is a cooker hood from Curry's. It cost me 40 quid. 3-speed fans, it's got a light in it, it does all the stuff. Was worth the money. Hang on, I think I might be getting ahead of myself. Yeah. Okay. What I really like about the laser is this. You can put the dot exactly where you want it to be, and it's a small dot. I think it's something like 60 microns. So you can cut fine things with it. Really like that. You have to pay extra for the software for driving it. Lightburn is what everybody recommends. There's a million videos on YouTube about using Lightburn, so they'll teach you how to use it in no time. It is really easy to use and worth the money. It's 50 quid. You can do clever things with it. So one of the things that I do with my laser is I make jigsaw puzzles for the family. So you've got to be able to register the cutting for the, the catastrophe. Go away. Right, you've got to be able to register the cutting out of the outside and the cutting out of the jiggly bits at separate times because they're separate operations. And you've got to be able to register those to the photograph that you're cutting it out from. Right? So the photograph's got some bullseyes on it, and you've got to register those with the bullseyes on the thing. Right? Lightburn allows you to manually put the laser over those bullseyes in the two cases, tell Lightburn where they are, and it will then rotate and scale the two things so that they accurately fit one on top of the other. Right? So I thought that was really clever. I'm a simple person, I'm pleased by simple things. What else have we got? Oh yeah. And also, going back a bit, if I can go back a bit, talking about Lightburn, the business about the extension pieces, because of this registration thing, and because the laser can be moved physically, if you wanted to do something 3 meters long, you could do whatever you wanted to do on this bit with some registration marks on it, move the laser cutter to the next bit, line up the registration marks using Lightburn, and then do the next bit all the way along. And there's a video of somebody doing I think it's an etching of a camper van or something that's 3 meters long. You know, it took him ages, but what the heck. Yeah. So you use it, also you can use it for cutting and etching, which is a good thing. Setting it up, it's no good having fabulous registration, resolution and so on, if it's not accurate. And the difficulty with getting the accuracy right is getting it to draw squares square, not parallelograms. So if you think of the chassis of the thing, it's two pieces like this and two pieces like this with a screw at each corner, and it's pretty much luck as to whether that's a parallelogram or a square. So I made this gadget, which I meant to bring with me, and it's one of the many things that I forgot. It's a piece of aluminium square tubing with some 3D printed plastic inserts, M6 threads cut in those, M6 studding. Each end has been turned to a point in the lathe. We've got a locking nut there and a couple of nuts locked on it so I can turn it easily. You stick one end in one corner of this chassis and adjust the other end so it just slides beautifully in the other corner. And then when you try that on the other diagonal, you see what your error is. And when you've got this adjusted right, it will just beautifully slide in both ends. It's a lot easier than fiddling around with tape measures and stuff like that. And if somebody wants to borrow it at some time, they're welcome to, because now I've used it, I don't need it again. Mouse wheels. You know, this is what everybody's interested in. This is why we buy things like lasers. It's for making MicroMouse bits. Whoops. Now, the thing about mouse wheels is you can buy mouse wheels fairly readily from all kinds of places, and they come in certain sizes. They don't necessarily come in the size that you want. If you make your own, you have a problem with fitting them on the D-shaped ends of these motor gearboxes. Classically, I have 3D printed wheels with the filament printer, and they come out nearly round and with a hole in the right place of some indeterminate size. So you end up having to put them in the lathe, and true them up, and drill a 2.95mm hole so you can force fit them onto the shaft of these things. Of course, the laser can cut D-shaped holes for you. And if you allow for the size of the kerf, which is 50 or 60 microns, you can make the D-shaped hole the right size. And you can build your wheel up from a series of layers that are cut the appropriate diameter for O-rings. And you can buy O-rings in almost any size and in lots of different materials. These, slightly for lightning purposes, but they also allow you to use registration parts. Pass that round. That's a wheel. This is what Wilf uses. So the kids are going to be whinging at me soon to make wheels of different diameters, and also probably wheels with different width tyres, because you can stack the O-rings out as far as you want. You can change the dimensions by 10% if you want different gearing, that kind of stuff. It's all ever so easy on the laser. And you just glue them together with PVA. Where am I?
You said there was different types of material for the O-rings. What's the best?
You can buy, obviously, the nitrile ones, which is sort of standard, but you can also buy silicone ones for food stuff, and they're nice and soft. Yeah. They stack it up like that, which is what I'm passing around. So, apart from making wheels, I also use the laser a lot for making jigs. I suspect these jigs are quite familiar by now. Right, so you just design it in Lightburn and bang it out.
Sorry, the bits that were sticking out the side of the wheel, the little square bits, what were they for?
They're for registration. So to stop the bits of the wheel from turning relative to each other.
Ah.
The bit that's on the D, you can rely on the D for registration, but you might want to make the wheel that wide for a drag racer, you know. So you might have 8 O-rings stacked out. And so you need registration. Yeah. So that's my jigs. This is just MDF. This is polypropylene or something which you can laser. There's quite a few materials you can laser. Unfortunately, these lasers won't do clear acrylic because they'll cut or etch whatever is on top of the acrylic and whatever's underneath the acrylic, but they won't touch the acrylic, they just go straight through. Clear acrylic, because it's blue light that you're using to cut. Right, talking of jigs, there's something I've used a couple of times which is really nice. Every now and then I have to do some sheet metal work, and you sort of design the blank of it, and then you print it out on a bit of sticky label, and you stick that on a piece of thing, and you put punches in and all the rest of it. Nowadays, I spray the piece of metal with a bit of black paint, design it whatever I want in Lightburn, stick it in a laser, and the Lightburn puts all the lines for me with an accuracy that I can't get anywhere close with any other method. And then you send a punch and drill and fold along the lines. So it allows you to transfer designs very accurately onto other materials. I can't cut or etch metal. You can sort of pretend to etch metal sometimes, but I can mark on the paint with that kind of accuracy, and that's really worth having. Right. It's used for lots of other things. You've probably seen the half-size ratification box. There's a website, boxes.py, I think it is. There's a link further on, where you put in the size of the box that you want and the thickness of the material and everything else, and it gives you the design back. You have to tell it what the kerf of your laser is, and it will make things that really fit. You know, if you haven't got the kerf right, you're hammering the things together. So you can make things like that. Mentioned before, jigsaw puzzles. I've scored lots of brownie points with family jigsaw puzzles. So you take a photograph of the entire family, print it out on a nice printer, make it into a jigsaw puzzle, put it into a beautiful box that you have laser cut, and give it to your beloved for a birthday present or something, and you'll score lots of brownie points. This thing was for this last Christmas gone. It's a perpetual advent calendar. Use boxes.py for the little drawers, put numbers and pretty Christmassy things on the fronts of the drawers. I had to do a tiny amount of design work for this front panel. It was given as a kit to our 3 children's families, and they built it as families, and they've now got perpetual advent calendars. Really good stuff. So you've got an excuse to buy one. And these are some resources. That's the boxes place. This place has got all kinds of designs for things. I've stolen from there or other similar places, designs for push together. There was one for a wasp, and one for a scorpion, and one for a rocket. Yeah, and you give them to kids and they have a great deal of fun with them. That's the jigsaw generator. So you put in the size you want, the number of pieces you want, how much variation you want in the pieces, and it gives you a file that you can import into Lightburn to cut it out. And you name it, you can probably get it from Google. Right. I think that is all I have to say about laser cutting. Any questions about that?
Yeah, did they offer a commercial enclosure that you've got for your laser cutter?
I suspect you can buy one.
There are several.
Lots of designs out there.
There are some you can buy if you go to Geek Buy and you get a frame and a fabric cover over it.
I've sort of stepped past safety considerations. It's got a little cover that stops you from actually looking at the actual laser, but technically it ought to be in a laser-proof enclosure. and I haven't put a laser-proof enclosure around it because I wanted to be able to see what it was doing.
So what always put me off iron one is that they're very easy to forget how powerful that laser is.
Yeah.
How reflective some surfaces might be.
They included in the kit is a pair of laser-proof goggles. Yeah, not sure how useful that is because there's usually more than me in the room.
But how heavy that hammer is.
Yes, but eyes are a little.
How sharp your circular saw is.
As long as you're not cutting reflective materials, and as long as you keep this little cover down so you can't actually see the point where the laser interacts with things, you're pretty safe.
A possible risk is if other people don't know.
Yeah.
You might be wearing the goggles and all that. I'm always wary that somebody will come and close the character, someone can wander in and get zapped by it. I've tried beckoning strangers, but
There is one bad thing about it. You can't leave it operating on its own. So if you've got some fancy etched photo that's going to take an hour or so to do, you've got to be there because every now and then it might burst into flames. That's just a sort of intrinsic side effect of the fact that you're burning away material. You can't do anything about it. So you have to be there. It hasn't happened to me yet.
But you can adjust the power, so if you want to etch, you just turn the power down, is that what you do?
Yeah, you've got the controls you've got speed and power. And for lining things up, you can set the power down to something like 0.05%, so it's just a nice bright dot, and then you can accurately position things. So you might, but for actual cutting something, you might set the power to 90% and the speed to, it's in millimeters per minute, so it's a bit difficult to understand, but you'd set it to 200 or 300 millimeters per minute, something like that, depending on the material. That black stuff, the 6mm black stuff, I also found impossible to cut, but the 3mm black stuff I can cut. So if we are, just going back to that a second, if we are laser cutting these things, we're probably going to have to be 3mm for the top layer.
strange thing is that if you, it's over here now, but if you look at that piece, one pass goes like 4.5mm straight, but then it chars up and fills the hole, and that's very absorbent, and then you can't get any further.
Yeah.
So that's the thing.
Yeah,
That's the
I was
limit.
just going to ask roughly how many passes does this thing?
Oh, yeah.
I assume it takes more than one pass to say
Yeah.
get through a piece of.
6mm MDF, I think, is about 6 passes for me, something like that.
Mm-hmm.
You know, I mean, obviously depends on the material and all
Yeah.
kinds of things. But I love my laser.
Yeah.
How-
It's managed to last a decent amount
Months.
of time. You've done tons of
I've
stuff.
done stuff with it, yeah.
Yeah.
Unfortunately, it's not my not my best love anymore since I got the resin printer. Right, okay, I've got one more little thing. Processor boards. Now, we're all familiar with this style of stuff, whether it's an Arduino or a Pico or whatever it is, right? They're all beautiful, but they're all a bit big. And I found these, which is an XMC to go. It's got a bit of a slug of an ARM chip on here. It's quite slow. But these were cheap. These were about £6, and they got 64K of flash and 16K of RAM, so you could do everything you wanted to do with them. And we used them on Wilf. Nice plug-in processor board. Right. Unfortunately, they stopped making it. So you can't buy it, and there's nothing that is hardware compatible with it. Great. So either I'm going to have to go to these, which in the small size I can't get exactly what I want, because the processors that STM put on this small size, the 32-pin versions, don't have more than 64K of flash on them. They're limited. So I thought I'll have to, this is a close-up of a bit of Wilf. This is where it is. That's the processor board. These are plug-in motor controllers. That's a plug-in Bluetooth module, and you've seen the plug-in sensors. So everything plugs in, and on this bit, everything plugs in vertically apart from that. So that bit of motherboard, you can't do much with. So that was another design input. So this is my new one, just for size, that one. It's an STM32 F072, 128k of flash, 16k of RAM, so it's got twice as much flash as that. It's got the same amount of RAM, it runs about twice as fast, it's got better ADCs and all the nice things. But the key feature is the connector comes out the end, double row. So I can mount it vertically, or I can put straight on connectors and mount it horizontally. But that's the key feature, that I got all the connectors at one end, which is really what I was proposing that you should think about, because that's it.
Sorry, you designed that?
Yeah.
Oh no, yours, sorry.
Yeah, I mean, you can't buy them, so you have to make them. And it's so you know, it's.
That's what we're all about, isn't it? Most of the stuff we want to do, we can't buy, so it has to get made.
So just in case it wasn't clear, you can either put the connectors on that way round, or can't unplug it.
I've contemplated making an adapter to do exactly that on an existing on another board. But
What we do, old card.
Or that way round.
yeah, that's right. Yeah, that's got more fingers.
Any questions on any of that? Have I bored you enough? Okay, great. Yeah.
What LEDs and photo transistors are you using on your sensors?
805 ones. They started off with photodiodes instead of phototransistors, but they weren't sensitive enough. So I've had to put phototransistors in there. Whatever was cheapest at Farnell at the time,
Right.
and the same for the red LEDs. They're nothing special.
So they're visual-wise?
Oh yeah, I don't use IR. I can't see what's going.
Yeah. You need an IR camera. I don't want to distract it while we work.
Yeah. No. I like visible light because the kids can see what's going on then. You know.
Yeah.
That's pretty much all I'm aiming at with a lot of this stuff, is getting the message across to the kids.